Hi, my name is Dennis Sang, and this is my DSC 478 final project. Basically, what I did was continue a final project in a previous class where I took regular season play-by-play data, grouped them into NFL data, grouped them into drives, and then ultimately tried to classify whether or not drives would result in a touchdown, 6 points, a field goal, 3 points, or a punt or no turnover, 0 points. So to kind of build off of what I did in the last project, I took play-by-play data, kind of cleaned everything up in terms of inconsistencies, plays that didn't make sense, and then I did some feature creation to kind of make sure that I'm setting myself up for when I group and aggregate everything into drives. And so plays essentially make up drives, and I want to make sure that things that I can identify within specific plays also carries over. So what is new in this particular project was that I also included additional features based on team defense data and team offense data. And so the previous data set was scraped from the NFL Live Game Center API, but I took data scraped from Pro Football Reference, which gives you for every particular year the team performance. And so I took this for every year and every team, and then essentially once I was able to kind of create the drive data, which is the first step of pre-processing, take this drive, team-specific drive data for every year, and then essentially merge that, join that to the drive table. And so that gave me a lot more features to kind of work with. Ultimately, once we created dummy variables, we ended up with about 75 different features. Because a lot of the drives features are very correlated, that's just the nature of American football. And we had some difficulty kind of coming up with trends through clustering. What I ultimately did was ran PCA and to kind of use that as a way to perform my classifications algorithms. And so we focused on decision trees primarily so that we could compare the results that we did from the last project with the new ones. So we worked on decision trees, we introduced random forests, and we also used KNN. And so for each of the three, we looked at performance using the new drive data set, so incorporating the team drive features, as well as just the original drive data set prepared. And so what we see is actually, when we look at the overall performance across all six, we notice that actually the decision tree and the random forest perform relatively similar, with the decision tree being slightly better. I think that because of the computational complexity, that we weren't able to kind of tune the hyperparameter as well as it could have been. Otherwise, I think the overall accuracy and the overall precision would probably been markedly, or at least at least higher than it is comparatively right now. KNN performed a little bit worse overall with accuracy, but a slight uptick in touchdown precision. And then finally, what we wanted to do is, once we had all these models, we wanted to kind of go back and say, okay, well, we had all this in terms of we tested it on regular season plays and drives. What if we took playoff data? And so we took a particular, also scraped from the NFL Live Game Center API. We looked at just 2017 and the playoff data for that. And what we ultimately found when we predicted using the three new classifiers, using the new full data set, is that actually the models do fairly well. At least two of them do. So the decision tree has lower accuracy when it comes to regular season performance, but precision is actually quite high relative to what we saw in the test data set for regular season. But ultimately, random forest performs the best, with KNN being quite poor. As you can see, the precision for touchdown accuracy for the playoff drive data is quite bad. So ultimately, in conclusion, what we essentially did was kind of to continue off of the work that we've done before, take the regular season data, add more features to it, essentially double the features, and then included some extra work on, and rather than just looking at one set of tuned decision tree and KNN, where we kind of expanded that to include random forest, and then doubled that to make sure that the new data set that we've created actually performs better training wise than the old data set. And what we ultimately find is that it does.